All right, so we're going to prove that if BY and CZ are altitudes of isosceles triangle ABC with base BC, then BY is congruent to CZ. So let's go ahead and start the proof. So we know triangle ABC is isosceles with base BC. This implies that AB, right? AB is congruent to AC. And by the isosceles triangle theorem, we know that if AB is congruent to AC, then angle B is congruent to angle C. All right. We also know that BY is an altitude. So let's go ahead and write that. BY is an altitude, which implies that the measure of angle BYC is equal to 90, which is equal to the measure of BYA, right? So we know both of these are 90 degrees, right? We also know, since CZ is an altitude, right? So CZ is an altitude, implies that the measure of angle, so CZ, so CZB, right? The measure of CZB is equal to 90, which is equal to the measure of angle CZA, right? CZA, right? So we know that CZB is 90 and CZA is 90. So we know both of those are 90. So look at what we have. We have these angles are congruent. These two angles are congruent, right? And BC is congruent to BC. So if we were to look at triangle ZBC and YCB, we know they were congruent by angle, angle, side, right? Angle, angle, side. So we know those two triangles are congruent. And if those two triangles are congruent, that means the corresponding sides BY and CZ are congruent. So let's go ahead and write that up. So we know that, so this implies that, so we want specifically that CZB, right, is congruent to BYC. So CZB, right, is congruent to BYC, right? Because they're both 90. So now we can go ahead and consider triangle ZBC and triangle YCB, right? YCB. So we know that CZB is congruent to BYC. So CZB is congruent to angle BYC. We know that angle B is congruent to angle C. And we know that BC is congruent to BC. So these three things imply by angle, angle, side, congruency theorem, that triangle ZBC is congruent to triangle YCB. And since ZBY is congruent to YCB, that means that BY is congruent to CZ, which is what we wanted to show.